At this time, I'd like to ask Dean Oliver Garden from the School of Veterinary Medicine to introduce today's presenter and the very interesting research we're going to hear about.
Absolutely. Thank you. Good morning, everyone. It's a pleasure and joy to be here. It's a particular privilege to introduce one of our senior members of faculty in the Department of Pathobiological Sciences, School of Veterinary Medicine here at LSU. He is Dr. Shafiqul Chowdhury, who is an expert in vector-borne vaccines for both bovine and porcine diseases, and you'll hear about the former today. He gained both his DVM and master at the Agricultural University of Bangladesh, and he went on then to Germany, in fact, to the Free University of Berlin, where he gained his PhD in virology. He undertook a brief spell at Bayer Animal Health in industry, and then went on to an illustrious career at academic institutions, including Kansas State College of Veterinary Medicine, and more recently, of course, here at LSU, and he joined us in 2008. He is the recipient of multiple awards, the Pfizer and Zoetis Research Excellence Awards being among two of them, as well as Excellence Innovation at LSU in 2016, and becoming a senior member of the National Academy of Inventors in 2018. His work is funded by USDA and the National Institute of Food and Agriculture. He's had continuous funding by the USDA for decades, and his lab currently is funded by two large grants, one that has just been announced, so we congratulate him on that. And he has particular expertise, as I say, in vector-driven vaccines in both bovine and porcine disease scenarios, in particular African swine fever, swine influenza, and bovine respiratory disease. So it's a pleasure to introduce our member of faculty at LSU Vet Med, Dr. Chowdhury. Shafiq, up to you.
Thanks for the kind introduction, and good morning, everybody. And I would like to thank also for the opportunity to share with you some of the things that we have been able to do at LSU. Can I use this? Okay. So just to start, give you some background. I'll be as simple as possible because I know the audience, and I will go through the slides which you have also. So basically, bovine respiratory disease is a complex and initiated by two important viruses, which I will briefly introduce in some simple terms. And then what happens is that those animals, especially young calves, and in the dairy industry also, the fetuses can be infected and aborted, the problem ensues, especially in beef industry, in feedlots. When they get infected with these viruses, it basically suppresses their immune system, and subsequently you have bacterial infection, which kills them. And there is hundreds of calves will die when they get this outbreak. The vaccines that we have, so it causes $1 billion loss every year, just the US cattle industry. The vaccine industries have vaccines which is 60, 70 years old technology. What they do is they take the original viruses, mix them together, and they basically propagate them in cell culture, not in the host, the animals, so that they lose their ability to cause disease. But they have all the other properties like suppressing body's protection, and sometimes they persist. The immune system cannot eliminate. So this vaccine is still prevalent because there is no new vaccines available in the field. So my lab has been working for many years to develop a vaccine which will be safer, because the current vaccines, they can regain virulence or disease-producing ability and kills, like this normal virus that do. So with that introduction, I will go quickly just to familiarize. So one of the viruses, bovine herpes, it infects through the nose, and then basically the virus is replicating and shed, causes respiratory infections, and that suppresses the immune system, invites some bacteria to do the damage it does and kill those animals. Pregnant cows, it can abort, so those fetuses will die. So it affects both dairy and beef cattle industry in a big way. And this is the main virus that also persists for life. Once the animals may recover, may not die, those that don't die, the virus gets into the nervous system and goes to the area called trigeminal ganglia, is just base of the brain and lives there forever. Time to time, due to stress, it will re-emerge and cause the same problems that I showed you earlier. And this goes on for the entire life. So this is what is shown here. So this is a major virus. Then the other virus that also is important is called bovine viral diarrhea virus. This basically infects through the nose or the oral mouth, and then causes respiratory signs, and again, bacterial infection will kill them. The virus can also go and spread through the whole body, through the blood, and causes abortion, like bovine herpes. And sometimes this abortion doesn't happen. Those calves that are born for life will carry the virus. So these have been a huge problem for the cattle industry. And this, together with bovine herpes virus that I just said, causes a major problem in the cattle industry. So as I said, this vaccine doesn't work because it is basically the real virus. They just changed it by propagating in cells, but it can regain virulence or become disease-producing. And I got calls just recently after this press release from some cattle man from Texas, and he said he just lost 200 calves. And after the vaccine that he used, this vaccine has caused deaths, even after 3 weeks after vaccination, because of the problem that I discussed. So what we did, so I'm just going, these are the things that basically tells all these things that I just told you. I'm not gonna read them, but so these vaccines causes more problem than solving in the long run. And in Europe, they banned all these vaccines, the modified life. They don't allow this, but in the US, we still use it because beef cattle industry, they didn't buy into that. So what we did is we took this bovine herpes virus and genetically engineered, deleted some of the proteins coding genes so that those that harm and makes this virus able to cause disease cannot do that, but have everything else that will induce protection in the host when we use that as a vaccine. So we use that. So basically there are 4 genes that we deleted. I'm not go over that. And then those deletion places where we deleted, genetically engineered those viruses, we inserted the proteins that protects against the other virus, just I told you. So this one virus that we engineered can be used to deliver or protect other viruses if we put their protective proteins. So this is basically the concept. And we are now using this virus to protect against not only these 2 viruses, some other viruses, and specifically against that bacteria that kills the animal subsequently and is the major issue. So it also protects from excessive antibiotic use, because in order to protect against death against that bacteria, we use antibiotics, which can cause problem, antibiotic resistance, and we are dealing with antibiotic resistance bacteria. So these are multiple things that can be solved by this vaccine. And we have companies that have licensed this vaccine, and hopefully in few years we can have USDA license for this vaccine and will be commercialized. So our vaccine is a multivalent, could basically replace that vaccine that is not working, causing more problems. So that's all what I have to present, and if you have any question, I'll be very happy to answer.
Dr. Chowdhury, I'm a cattle farmer, so I have a question. Is this something that you can foresee as it's more widely used will provide antibodies in the offspring of the vaccinated cattle?
Yes, absolutely, yeah.
So
it has
cost savings down the road.
Oh, yeah.
Which translates to our beef market in the United States.
In fact, when we test those vaccines in cattle in a small scale, we actually compared with the Zoetis vaccine that they're being used now, and our vaccines performed way better, and we published these results. And if you are interested, I can share those with you.
I'd love to have that information. Thank you so much. Is there any other question or comments?
Just for cows? Only cows?
Excuse me?
Only beef?
No, I have also a vaccine that we developed for the pigs, which I'm not sharing today, we don't have time, but That's a major, major problem. You know that African swine fever, which is not present in the US currently, it has happened in Haiti and also in the Dominican Republic. In Europe, it's causing a havoc. In Russia, Romania, in China, which is the major pig producing country, half of the population of the world, it killed 50% of the pigs. So I have been funded through USDA 2 grants. The first one was the virus, the similar herpes virus for pigs, which is called pseudorabies virus. We engineered the same way that I showed here, and we expressed classical swine fever, which is another problem and killed a lot of animals, and porcine circovirus. And that has been tested in Plum Island, and it has been very good, protective, and also against PCV2. Now, last year I got funded for the African swine fever, which I'm doing the work with Canadian Vido, which is a very, very well-known industry vaccine company, and also universities. So that's my collaborator there. So we are developing the vaccine here. It will be tested over there in the BL3 Ag facility, which is because the virus we cannot use in the lab here. The other grant I just got this year is actually for porcine respiratory and reproductive syndrome virus called SPRS. It's a huge problem for the pig industry, especially piglets, and then also swine influenza. So I got also partnership grant with Ohio State. The animal work will be done in Ohio State. They have the facility because it's a very highly contagious virus. So I am using this technology not only for bovine and pig. I could use it for dogs, cats. They also have herpes and other viruses. The more importantly, the current outbreak of influenza that you see in the dairy cattle, you have seen that in the newspaper. I think that this vector that I just showed you, I could very easily make it against influenza for cattle. Okay, that would be protective. So it will be very simple. Within a year, I can make it, and then we can test it against that. So this technology, it took me a long time, first in Kansas State, then here, but it's so standardized that we can do it. We can make these viruses within a couple of months, actually.
What is the timeline from where you are now to, like, for hitting the market, affordable
Right.
for?
So the vaccine that I presented has been with the LSU signed a licensing agreement with a smaller company, and due to COVID, there was a break, right? 2 to 3 years, we all suffered. So it delayed, but they're now progressing, and hopefully within a year or two, we should have. They're just doing their due diligence and the experiments that they have to show to the USDA to get the license. So hopefully we'll be successful within a few years. That's my hope.
Thank you very much. Any other?
So this, what he's doing, he creates this vaccine. Is that true?
Oh, yeah. The patent has been filed here. We filed several patents, and we got awarded several. Some are pending, and so LSU owns this. So we have licensing agreement for the bovine herpes vector. The PRV, we are pursuing that. The patent is pending, and hopefully we will get some. I know that SIVA was interested, but then swine market went down after the African swine. It killed 50%, and people stopped eating pigs, pork in China because they were so expensive. I'm originally from Bangladesh, but I lived most of my life outside. Right, I hope so. But yeah. Thank you very much for the opportunity.
Thank you so much.